Hello and welcome to System Administration. This is Episode 3, DHCP and DNS in Windows. I've changed the way I'm going to be recording these videos over the last couple of weeks, and I had to record this video 5 separate times, so hopefully here's hoping this one works. What I'm going to be doing from now on is I'm going to break these down into the different OSs and also the different services. So instead of the situations where I had the install for both OSs at the same time, I'm now going to do DHCP for Windows in this episode, DHCP for Linux in the next episode, and then DNS for Windows the following episode, and DNS for Linux the episode after that. This will hopefully make it easier for you to search for the specific topic you're looking for, but it also means that the videos will go from being a 30-minute epic to a 15-minute half epic. That's what I'm hoping anyway. We'll have to see what happens as the episodes come around. So today we're going to do DHCP and NTP for the Windows Server 2012 R2 platform. You'll see here we're at the dashboard for our server and everything's ready for us to begin. So we're going to go up the top and we're going to go to Manage. And then we're going to go Add Roles and Features. In a future video, I will go through this Add Roles and Features wizard, but right now I'm just going to quickly step through the little bits and pieces that we need in order to install our DHCP service. When we click on the service, you'll see that it will offer the ability for us to install the management tools. Now, because we've only got one server, we will be installing the management tools. But in Season 2, when we have multiple Windows servers, you won't do this on every server. This option is only here if you actually want the services installed. We're going to this time. In future episodes, I may not. We don't want any other features installed at the same time. And we're just going to quickly click the Restart Destination Server. We're going to hit yes, we do want to allow automatic restarts. I'm going to hit Install. And then I'll come back once it's actually finished installing. And the cat stops screaming at me. And we return. So you can see now, we've finished the installation. And we've got two different options we can now complete. In the box that details what's happening during this process, you'll see it says launch the DHCP post-install wizard. We are going to click on that, but our other option is just to close the window and go through it manually. So we click on the complete DHCP configuration, and you'll see it's going to ask us to set up the following security groups. We'll go into all the group dynamics much later on, but for the time being we're just going to hit commit. Let it apply the groups, hit close, and close down the wizard. Now you can see down the left here, we have a DHCP service. If we click on the DHCP service, you'll see we get all the same details as we would for a local server, but there's no configuration in here. That's actually done through a tool, through the DHCP administration tool, which we installed as that feature. So up in Tools, you'll see we now have a DHCP tool here. We're going to click on that, and it's going to open our DHCP service. I'm going to expand this out into full screen, make things a bit wider so we can see what's going on. And we're going to expand out our server. We are currently on the TVL2-DCO1 server. So I'm going to expand this out. I'm then going to expand out IPv4. We will deal with IPv6 later. For the time being, we're going to be really safe and just deal with IPv4. I'm going to expand out the scope, and I'm also going to expand out the features. The filters. Under IPv4, you have server options. These options are the options that get handed to servers and computers and any device that asks for the DHCP for a DHCP address. Server options are things such as the DNS servers, gateways, the NTP server. There are also things like the SMTP server, the POP and IMAP servers. Phones will want the PABX address. Certain wireless access points will want their controller. Those sorts of things are all configured here across the server. You have to be very careful. Server options is for all scopes on this server. Scope options, which is underneath our scope, is exactly the same, except that it's only for that specific scope. It doesn't affect any other scope on the server, it only affects the scope that you have set the option in. This is a very critical difference. You must recognize it. Underneath the scope, you'll also see we have an address pool, which is where the start and end addresses for our DHCP pool are. And you can set up multiple different address pools inside of the same scope, should you want to. Normally you don't. Normally you would set up one massive scope, one massive address pool, and then add exclusions like it says here. It's up to you how you want to do it. I'll go through that in a later episode. Address leases talks about what clients have leased what IP addresses. Reservations are a way of forcing a device to always get the IP address that you want it to receive from your DHCP server. Now, a reservation is generally only used for things like printers or possibly for access points. There is an argument to having reservations for a lot of devices. There's also an argument for not having very many reservations at all. I'll go into the differences between these two, but for the time being, you just need to know what a reservation is. You'll now see we have two separate policy folders, one inside the scope and one inside the server. These policies are exactly the same as the server and scope options folders. They apply the policies to that scope or to every scope of that server. A policy is something that allows you to stop people from accessing certain things, or to allow people to access certain things and no one else to access them. It can turn on data logging, it can turn off data logging. We'll go into the policies in Season 2, but for the time being, you just need to know that folder exists. Policies are actually tied into network access policies, which is something we haven't covered yet. But when we get there, you'll see why there's a policy folder here and why it applies to both the server and the scope. And finally, we have filters. And as it says in the description, a filter is a way of denying MAC addresses or allowing MAC addresses. Now, MAC filtering is not a great security feature, mainly because people that are trying to access your network will just spoof a MAC address. There are situations where MAC filtering can be useful. Do not rely on it as a security feature, however. It is not a security feature, it is merely a useful tool. You'll realize we haven't configured anything in this episode. Now that's because in 4 episodes time, so not the Linux episode, not DNS, and not the Linux DNS episode, but the episode after that, I'll be going over how to start designing your network. In that episode, we'll cover how we're going to set up our address pool, any static leases we have, any scope options we want to set. We'll go through all of that then. But right now, I just need you to know how the DHCP server can be configured and kind of how it operates. Now, DHCP is a very simple process. When a computer is plugged into the network and switched on, it will go out to the network and broadcast to its whole subnet. Well, it actually does a MAC broadcast and says, where is the DHCP server? And the DHCP server then responds and says, I am here, please talk to me. The computer then sends the DHCP server a packet saying, I would like an address. The server will then respond with an address, any options, and any... it'll stop at options, because the policies are actually applied by Windows. These policies may not actually affect Linux, depending on exactly what the policy is doing. Most of the policies that go into a Windows DHCP server are for Windows network access policies, and some parts of those do not affect Linux. That, however, concludes our DHCP section of this video. We're now going to look at NTP, which is something that you've all done work with, but you may not have thought of it. If we go down and click on the clock, you'll see we've got change date and time. And if we open that up, we've got date and time, we have additional clocks, and then we have internet time. Internet time is actually NTP. NTP stands for the Network Time Protocol, and it is a way of getting the date and time from a server. Now, that sounds really, really, really simple and not something you'd really want to worry about, except that a lot of Windows services and authentication, and as a matter of fact, a lot of authentication across the globe is reliant on time. If you have two Active Directory servers and they are more than 2 seconds apart, they won't be able to communicate with each other because their Kerberos logins, the Kerberos connection that they share, will note that one of them is 2 seconds older than the other and will stop that connection in case of a man-in-the-middle attack. This, however, raises a problem. If you can't synchronize all of the clocks, how do you know that you're going to be able to communicate between the servers? That's where NTP comes in. Now, in Windows, you can't really do very much with NTP. It's very simple. You either have it set to a server or you don't. You can choose different servers. Like if I go change settings, I'm allowed to type in a server and that sort of stuff. But I can't set any clock skews. I can't change any static settings or offsets or anything like that. When the Linux episode is released, you'll see that there's a lot more configuration on the Linux side for an NTP server. Windows just gives you the option to set a server and go from there. Now, if I change this and go to time.windows.com, I can hit update now, and it will synchronize with time.windows.com. That's all the NTP settings you get to play with from a GUI perspective. There are some more regedit settings, but we're not going to touch them. There is also an NTP server. Now in Linux there's actually an NTP server, and I'll go into that later. But in Windows, it's a registry setting. And there's also a problem. Windows Server 2012 R2 and prior do not offer a high resolution NTP service. The NTP service that's running on this Windows Server 2012 R2 server is only accurate to the nearest second, which is okay and works for authentication. Windows Server 2016, however, fixes this problem. It is now accurate to the millisecond, provided you are within 1 millisecond ping of the server. That practically concludes this episode. I hope this worked properly. Give me feedback on it. I know this seems like a very weird sort of eclectic episode, but that's because I've recorded it 6 times now, and the more I record it, the more I change the way I was going to do it. So I hope this works well. Let me know, leave comments. I've been Jordan Keith. This has been System Administration, and I'll be uploading another video real soon. Thank you.